Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our physics demo. We spent a lot of time building these functions over the last few videos. Now what we're going to do is we're going to work a little bit on cleaning up our main. We're going to do several things, including breaking this up into multiple files, and also triaging the command line switches a little bit better than we did in the earlier videos. So to begin with, what we want to do is we want to look at our main. We're going to scroll down. You can see that we've made a pretty big mess of it, to say the least. We've got a lot of code that has been commented out, including some examples here from our previous video, our beam. What I'd like to do to begin with is I am literally going to go ahead and take all of the code after the variable declarations, and I am simply going to Control X or remove it. I'm going to open Notepad and I'm going to paste this for use in a later video. All right, so don't worry, that work is not lost. If anything, what we're going to do is we're just going to spend a lot of time in this video trying to clean up our main. The motivation behind it is that you would like to have one executable that could possibly run multiple functions. And so our goal here is that we want to be able to use this physics demo, this driver, this executable, and specifically this main, then to be able to call any of our 12 physics examples here. And so the first thing that we want to do is a quick reminder of how our arguments work. And so if you recall from the last few videos, we were leveraging the command line arguments. The 0th argument, or the index 0 argument, is the name of the executable. And then anything that follows that executable then becomes arguments 1, 2, 3, and so on. And so effectively what we're going to do is we're going to leverage this argc and the argv, where argc is the count or the number of arguments, and argv is that array of arguments. Now, what we want to do is we want to first look at our functions. And normally we don't do this at the functional level. It's just that the whole purpose of this particular example is to drive these functions. And so what I want to do is in the comments here, I simply want to track how many arguments I expect it to take to call a particular function, and then the arguments themselves. So we'll start off with the easiest ones, and you'll probably want to go back to one of the earlier videos to verify how this works, because we won't really be doing that in this one. But if you recall from watching the earlier videos that the name of the executable is your 0th argument, so you always have at least an argc equal to 1. From there, then you want to be able to specify through switches or through command line arguments which function you would like to call. And so we're going to focus in on the Projectile 1D version 1, 2D version 1, and beam version 1, because all three of those functions require no command line arguments. So how do we differentiate then between calling the 1D version 1, 2D version 1, and the beam version 1? Well, the first thing we want to do is we want to provide to the executable a switch that indicates which one of the physics functions we want to call. Now, you can make this pretty elaborate, but at least for this particular example, there's really kind of an obvious delimiter. An obvious delineation between the names here. So we're just going to call this one 1D, so /1D. And then the next one is going to indicate which version of the projectile function we want to call. In this case, we want to call version 1. So this will take a grand total of 3 arguments: the name of the executable, the /1D, and /1/v1 to indicate version 1. Now, We're going to go ahead and look then at projectile 2D, which is also going to require 3 command line arguments. In this case, it's going to be 2D version 1, and then the simply supported beam, which is also going to require 3, which is going to be the beam and V1. Now, continuing with this theme, we want to take a look at the number of switches required to call the projectile 1D version 2. And this one's going to be a little bit more complicated because we can either call this function interactively, where we have a scanf or a printf, excuse me, a scanf and a printf, or we can leverage a command line argument. So we've got a couple of different modes in which we can call this. So the first example is going to be whether we call this interactively, okay? And to do that, then we would require a /1D version 2 and interactive, which means then this would require a printf and a scanf, which means that we would wind up with a total of 4 input arguments. Now, the other possibility would be to provide it with a 1D switch, the /V2, and parametric mode, which would require then that we pass the parameters on the command line. And so if you recall, when we were doing this example originally, we were using 100 feet as the initial Y. So you would simply pass then as a final argument the height or the Y init. And so now you will see that we would have a possibility of 5 arguments. So basically there's 2 different ways that you can call the projectile 1D version 2. Now, continuing on with this theme, we can take a look now at the projectile 1D version 3. The projectile 1D version 3 can also be called either interactively or parametrically. But if you notice, there is really no change in the number of input arguments in either scenario, merely what the input arguments are. And so, give you an example here, we would still have 4 input arguments. It would still specify the first one as 1D, but this time around, it would be version 3 instead of version 2. You would specify interactive, which would mean that you would have to have a scanf and a printf, or rather a printf and a scanf, I suppose. But then you would also have 5 if you were interested in calling 1D version 3 parametrically, in other words, from the command line, and in which case then we're going to once again provide the 100 as the initial height. Now, we're going to come back to the version 4 in just a second. First, I want to follow up now with the projectile 2D version 2. The thing to consider first is which version of the projectile function we want to call. In this case, it's going to be 2D, the version 2, much like the earlier example, and then whether or not we want to call it interactively or parametrically. And in the case of calling it interactively, there is no more information that needs to be passed, so you would wind up with a total of 4 input arguments. The other possibility would be if we were to call it, call 2D, we would call version 2, and we would call it parametrically, then we would have to provide it with a v-init and a theta. Now, if you recall from the previous video, we provided it then with an initial velocity and a theta, and we used an initial velocity of 100 and 0.785 for our theta in radians. But if you'll notice now, I have a total of 1, 2, 3, 4, 5, 6 arguments, because remember that we need to include then the executable also as an argument. Now I'm running out of room here horizontally, so what I want to do real quick with this last example here, with this example for version 3, is I'm actually going to shift my comments around just a little bit. So I'm going to put this one up here. I'm going to put the next one then, if you'll notice, there's going to be no change there for the version 3. Just like with our version 2. So I'm just going to shift all of our comments above so that we can see the corresponding switch examples here for each one of our physics examples. All right, and then once again, we're going to leave the version 4. We're going to tackle that one in just a second. Well, now what I want to do is I want to look at version 2 of our beam problem. And so for version 2 of our beam problem, we will need the beam switch to indicate that we want to do the beam problem. We'll need a /V2 to indicate that we want to do version 2. And then just like before, we'll have a /I for interactive, which gets us once again at a grand total of 3 switches. The other possibility would be that we provide it with a beam switch /V2, but then we also want to indicate parametric mode, in which case, as arguments on the command line, we want to provide the weight, the length of the beam, and the location of the load. And if you recall from our previous examples, we had 100 for the weight, the length of the beam was 10, and the A, or the location of the load, was 6, in which case I now have 1, 2, 3, 4, 5, 6, plus 1 is 7 arguments. And just like in the other examples, there is not a significant difference between the number of arguments required for the version 2 or the version 3. The main thing that changes just simply is that second switch to indicate that you want to now run the version 3 of the problem, because the number of input arguments to the function does not change. We merely pass 2 additional variables by reference. We are once again going to look at version 4 in just a second. Now, going back to Projectile 1D version 4, you'll notice that I have an additional input argument and on the end, and that is going to be our n. Now, what we want to do is we want to handle this in our switches, but for right now, we're still going to leave the n as a hard-coded value, and we'll come back in a later video and show you then how you would dynamically adjust the size of the array for our time, our y time, and our vy time. All right, but for right now, what we want to do is we want to focus on the fact that for Projectile 1D version 4, we will in fact just have 4 input arguments, or command line switches rather. One is going to be the executable. We're going to have our 1D, our version 4, and /I for a total of 4 arguments. And then for the interactive, or excuse me, for the parametric mode, we would have not 5 this time, but we would technically have a 6, which is going to be our 1D, our version 3, parametric, and then what we want to do is, in addition to the y init, we would also specify the value of n. So in this case, I'm going to go ahead and put 11. Once again, it's going to match our n for right now. We'll come back and figure out how to deal with that a little better later. Now, for the Projectile 2D version 4, it's going to be very similar. The interactive does not change. The only thing that changes there is the value of the V switch. So we go from V3 to V4. We also then increment or increase the number of arguments that are needed from 6 to 7 for the 2D version. So it's going to be 2D version 4 / P. We want to specify the V init, the theta as 0.785, and then a total of 11 data points. And then lastly, for the simply supported beam version 4, we are going to accept 3 arguments, a beam and version 4, as well as a /I, and I believe I've made a mistake here actually. So under the beam, it was actually supposed to be 4 arguments. My apologies, because we actually do have the executable, the name of the function that we want to call, and then the version of the function we want to call. So these were all supposed to be 4. The only one that's going to be 3 then is version 1. Okay, because there is no difference between the interactive or the parametric mode. And then for the total number of switches then, or arguments rather, for the parametric version of beam 4 is going to be 8, with beam /V4 / P, the 100 again for the weight. The length is going to be 10, and our A is going to be 6. But we have a little bit of a problem here, because we also need to include the number of data points. Okay, so our N. So in this case, it's going to be 11. But the thing to note here is that with this last example, we're going to have a little bit of a harder time, because we need to have an array for A as well as an array for W. And so what we're going to do is we're actually going to come back to this example, and instead of providing a single value for A, at least for the first pass, what we're going to do is we're going to reduce this count back to 7. And we're going to assume that this load W is applied at 11 different points across a 10-foot long beam. And this matches the example that we did earlier. We're actually going to take a look in a later video at several different options here to be able to provide essentially a loading function, as well as a vector that provides the location for each one of the loads. But once again, we'll come back to this one. So our last step here now is going to be to create one additional function that is going to act as a helper function, and it will actually display the help associated with our physics demo. So we want to go ahead and put the function prototype here, and then down here at the bottom, what we'll do is we'll go ahead and create our helper function, our help function. Now notice it has no input arguments and no output arguments. We could do that a couple of different ways, but we're going to just start off simple, and then inside the help function we will print out the help associated with calling each one of our projectile and simply supported beam versions. Now, the first thing that we want to do before we get too much farther is we want to document what we're doing here, because we're going to be doing a lot of scrolling up and down. And so what I would recommend that you do is do a screen capture of this portion of the video. So just go ahead and just screen grab, and then maybe open up PowerPoint or something along those lines. And then basically just keep a copy of this particular screen, because we're going to be coming back to it pretty often to be able to keep track of our switches. Now, The whole goal here is that we want to use our argv and our argc to be able to control which one of these functions gets called and in which mode. And to do that, we want to sort of look at a commonality between all of these different switch combinations. And so if you notice, there's essentially a family of 1D switches, a family of version 1 switches, and so on. But also you should note that there is no valid combination in which you have less than 3 switches. Okay, so the argument plus 2 switches, so a total of 3 arguments. So there's no valid combination for which we will have less than 3 arguments. So that's going to be sort of where we're going to start this problem off with. So the other thing I want to do is I want to take just a second and I want to get us started on that help function, some content for the help function. So what I'm going to do is I'm actually going to copy all of this. Now we're going to do a tremendous amount of deleting here, but I just figured it would be easier just to go ahead and copy the whole thing. And I want us to come down here now to our help function. And I'm not going to complete it in this video, but I want to show you how to get started with this. And so I'm going to delete all of our function calls. So I'm just going to delete all of the prototypes out of here, rather, not the function calls, but these prototypes. And I just want to be left with our comments. It was kind of the purpose of the comments above was to sort of get us a start with our help file. And this will take a little bit of time, but once again, I just want to get you started on this. And the idea here is that our help will essentially provide the user with some idea of how to use your application. And in addition to providing some information about the application, we also want to provide some usage examples. So I'm going to start off with a printf statement, and I'm just going to simply have usage here. And then underneath this, what I want to do is I want to include then the name of the executable. So in this case, it's going to be physics _demo.exe. And then what we're going to do is we're actually going to make multiple copies of this. So as a matter of fact, if you want to go ahead and start off by making several copies of this, let's see, as a matter of fact, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 different ways that we can call our physics demo. And once again, I'm not going to do all of them in this video. I'm going to start with a few. So we'll focus on maybe 5. And then what you want to do here is you want to simply use these comments that we created earlier to show the user how they would, in fact, call your physics equations. All right, so I'm going to keep them in the same order that we generated them in. So we'll move that here and so on. And hopefully you can see that, yes, this is going to be just a little time consuming, but if you spent a little bit of time on your comments, you've actually made it pretty simple for yourself. Nothing too bad here. All right, so I'm going to stop once again with 5. I'll tell you what, we will go ahead and do our version 4. That way we can say that we have at least completed all of the physics 1D. So we'll go ahead and copy, cut. And then the last one, of course, is going to be the 1D version. And I think I might actually have a typo here. Yes, it looks like it. So I've gotten a little bit lackadaisical there. All right, and so we can go ahead and strike those off the books, and we'll need to, of course, do the rest of them here. I think I'm missing a double quote, but the idea here is then that this is going to just simply be printed out to the user. The other thing you can do, it's just a nice habit, is to go ahead and maybe tab these over. Once again, it's aesthetics. If you rename your physics demo, you can either change the hard-coded name. There is a way that you can also leverage the argv square brackets 0 by passing that to the void. Instead of passing nothing, then you would pass a character vector that would specify the executable name. If we get a chance to, I'll show you how to do that in a future video. But this just helps to set up our help. Now, let's go back to the top. And once again, hopefully you've taken a screen capture of this. Let's get started now on triaging our switches. And we said that none of our options use less than 3 switches. So to begin with, we can just simply say if argc is less than 3, we have a problem. And specifically, that problem is that we need to call help. Okay, so right off the bat, we've handled that. Now, what you can do now is you can decide whether to triage the remaining switches in linear fashion or based on some sort of hierarchy of the 1D, the version, and whether they are interactive or parametric. And so what I'm going to do is I'm actually going to do sort of a combination of the two. So then under the else here, so in other words, the only way that I can get to the else is if I have 3 or more switches. I'm going to start off and slowly pick away at each one of my options for each one of my physics examples or physics demo. And to begin with, what I'm talking about, I'm going to first look at argc equal to 3, and I'm going to use a function called string compare I to compare what would have been the argv1 and argv2 to determine which function you want to call. So in other words, if argc, of course spelled correctly, if argc is equal to 3, and then what we do is we compare argv square brackets 1, and if that matches our slash 1d, so if that's equal to 0, in other words, there's no differences there, and our string compare I of our argv square brackets 2, and that matches then the version 1, so that's equal to 0. If all 3 of those things are true, then that means that we want to call our physics example, the projectile 1D version 1. And remember, that accepts no input arguments. It returns no output arguments. So in other words, all of that is handled inside. So for this particular case, all we need to do is simply call the function. Now, at this point, what we can do is we can continue on with this theme, and that we can do an else if. And just like before, we'll check to see if argc is equal to 3, and the string compare I square brackets argv square brackets 1, if that matches the slash 2D example, and string compare I argv square brackets 2, if that in fact matches the version 1, and if that is equal to 0, well, that means that we call projectile version or 2D version 1. And then hopefully you can see here where we would just continue. As a matter of fact, I'm going to emphasize this. I'm just going to simply copy and paste this line. And the only thing that then gets changed here is instead of the 2D, we simply have beam. And in this case, then what we do is we call our simply supported beam version 1. And you could have grouped this a little differently. As a matter of fact, let me show you what I mean by this. In that you could have started off with a switch that simply said if argc is equal to 3, and then inside of here, then you would simply check to see the other two remaining conditions. So you would have something like this, else if, and you would essentially nest your conditions. All right, and then so we have else if, the third one for the beam. And then from there, then you would just simply have an else, and the else would simply call the help. Either approach is fine. It does not matter necessarily which one of the two you want to do. So I'm going to go ahead and leave this one here in the comments. We may delete it in a future video, but the idea is that you can at least see then this equivalent nested if statement. So one does a little more flat, the other one is nested. Okay. All right, once again, it's just about the patterns. If you can establish then a pattern in each one of your examples, then from there you can figure out the best structure for your if statement. So what I'd like to do though is, since we focused on the number of arguments, I'm going to continue with this more flat structure here. And I'm just going to go ahead and comment this out and leave this for you to think about. Now, if we have managed to make it this far, we're essentially into our version 2s. We have a couple of different options here that we can choose. We can either group all of the 1D, 2Ds, and beams together, or we can just continue on basically with each one of the options, just continue on with our triaging. I would prefer to actually group similar versions of the problem together. All right, so meaning that what I'd like to do is here, I'm going to come back now to this portion. I'm going to insert now an else if. And what we're going to do now is we're going to focus on all the different combinations of the 1D problem. So if anything, what we're going to do is we're going to now look at the Projectile 1D version 2 in both its interactive and its parametric modes. And so in its interactive mode, we said that it would require a total of 4 arguments. And those 4 arguments, the string compare I, we would use to compare the argv square brackets 1 to see whether it matched the 1D. And we would use string compare I then to look at our argv2 . And in this case, though, we weren't looking for version 1 anymore. We were actually going to be looking for version 2. And I have dropped my equal sign here. Let me go back and put that in there. There we go. And then now this one would be equal to 0. And then make sure we're not missing any parentheses. There we go. And then the argv3 would either need to be a /i or a /p, but specifically since we've specified that there is argc equal to 4, we ideally would want this to be a /I. So in this particular case, then our string compare I should be looking at argv square brackets 3 and hopefully finding a /I, in which case then we want to run our equations using interactive mode, which means that we have to capture the y init from the user. Well, we saw how to do that earlier in that we first provide a prompt to the user, in this case, printf, please enter a height. You can choose to provide the units, followed by a new line, and then a scanf, where we provide the data type. So in this case, it's going to be %LF and the address of our y init, at which point then we can simply call our projectile 1D version 2, and we are going to pass to it then our y init. Now, the one thing to note here is that in this particular case, we are going to be printing the table inside the function. So we collect the information outside the function, we print the table inside the function. So just keep that in mind. This will get a little more complicated as we go along. Now, we've handled the interactive mode where we prompt the user. Let's now handle the scenario where we are getting the argument parametrically, in other words, from the command line. So in that scenario, if you look back at your notes, we said that argc was going to be equal to 5, and there's going to be a little bit of redundancy here. The string compare I is going to look at the argv1, and it's going to compare it to 1D. And if that also matches, and string compare I argv square brackets 2. This is going to be /v2 if that's also equal to 0. And the string compare I of our argv square brackets 3. But this time around, we compare it to /p. If that's equal to 0, then that means that somehow we should be able to get our y init from the command line. And I see I have a typo here. I was noticing that my lines were not the same length, and I kind of expect them to be. And we saw how to do that once again in an earlier video, and that was going to be using the A2. Sorry about that. It's here A2F, in which case what we're going to do is convert argv square brackets 4 into a double, and then we simply turn around and we call our projectile 2D version, or projectile 1D version 2 rather, and we pass to it the y init. All right, so continuing on with this theme now, we're going to be looking at the 1D version 3. So 1D version 3, if you notice, if you go back to your documentation, that the 1D version 3 accepts the same number of input arguments in interactive mode, and it also accepts the same number of input arguments in parametric mode. The main difference between the two is just simply the value of argv2. So what we can do is we can actually borrow a little bit of code here. So we're actually going to come up here. We're going to borrow this code, and I'm actually going to hit enter a couple of times here to give us some extra room so we can have a break from our 2D problem for right now. I'm going to paste this in here, and I'm going to make sure to close my brackets. There we go. I've got that now. I think I've got my brackets matched up. And the big difference here then is going to be that instead of a version 2, I'm going to call version 3. And in both cases, we are going to get the information from the user interactively. So we're going to go ahead and use our printf and our scanf. But the big difference now is that our Projectile 1D version 3 is not responsible for printing anything. Instead, remember that we are using by reference variables. So in other words, we actually have to handle the printing of the table. So the first thing we want to do is we want to call our Projectile 1D version 3 with the correct variables. And so you'll notice that we have a y init that is by val, a t final, a y final, and a vy final that are all by reference. So we're going to start off with our y init. We're going to do an ampersand t final, ampersand y final, and then an ampersand vy final. And then from there, we need to print our table. Now, I'm going to do this for this example, and then I'm going to let you guys finish this out. But what we want to do is we want to go back over to that notepad that we had earlier, and we want to go through and we want to find that table in which we were actually doing our 1D or Projectile 1D version 2 and version 3, where we had this nice little table already created. In which case, I'm just going to come in here and I'm going to borrow this. In other words, Control C. And then I'm going to paste it in here inside of this branch of the else if. And so now what happens is we get this nice table as an output whenever we call our Projectile 1D version 3. Now, as I mentioned just a few minutes ago, you have that same number of arguments in our Projectile 1D version 3 and version 2. For instance, if you had called it interactively, in both cases you got 4 arguments, but if you called it parametrically, in both cases you would expect a total of 5 arguments. So what we want to do is you want to come up here now and you want to go to your version 2, the parametric version. You notice that it requires the 5 arguments, 1D version 2, and then /p. The only thing that we're going to change here is we're going to change it from version 2 to version 3. And then additionally, we want to go ahead and capture our y init. So we'll go ahead and type this. That's not that bad. So it's y init is going to be equal to a to f of our argv square brackets 4. And then this time around, of course, we want to call our Projectile 1D version 3 with, once again, our y init, our ampersand t final, ampersand y final, or the address of y final, and then also the address of our vy final. And then we're faced with printing out the table. Now, there is another way that we can go about doing this, but for right now, we're going to have, for this example, just a slight bit of redundancy in our code. Okay, so there is a way to get around this, but once again, I wanted to keep the if structure relatively simple. And so, yes, there's going to be a lot of code in this example. However, sometimes you can't avoid a little bit of redundancy, especially in your presentation. Now, this brings us to the Projectile 1D version 4. In the Projectile 1D version 4, when it is run in interactive mode, accepts 4 arguments. So we could actually go grab our example from above, or we can just simply talk our way through it. So in this case, it's going to be equal to argc equal to 5 and string compare I of our argv square brackets 1, and we're going to compare that to the /1d, and if that is equal to 0, and string compare I of argv square brackets 2 compared to now /v4, if that's equal to 0. And then lastly, string compare I argv square brackets 3 compared to /i 0. And then we have 2 pieces of information to capture. So we have our printf. Please enter, I want to verify how I did this up here, enter a height. And we're going to specify feet. And a new line, followed by a scanf with a %lf and the address of the init. Then we also have a second prompt, in this case a printf, please enter the number of points. And this is going to be a integer, so %d. And that is actually going to be our n. Now I'm going to put a little note here. Okay, note, we need to address this later. And what I mean by that is in this video, I'm not going to talk about dynamically creating our vectors. I'm going to assume that right now that they have been created for us. So if anything, in this case, our n is going to be equal to 11. So if you enter in any other value, you're going to have a problem. So rather what we're going to do is we're going to focus on that in a separate video. And then what we're going to do then is, just as a little note here, I'm going to set n is equal to 11, note, remove later, and then we'll just simply call our Projectile 1D version 4. We're going to pass to it a init. We're going to pass to it a time vector, a y time vector, a vy time vector, and then lastly the n, which represents the number of elements in the vector. Now, from here, we need to print out our results. So we need to print out the table. And if you recall from last time, the video on the 1D, the table got pretty sophisticated. There was actually 2 parts to it. One was the start and end values. So I'm just going to go ahead and once again go over to my notepad here, and I'm going to copy and paste that first table. And so that looks very, very similar to our example from earlier, where we just had our init, final, and so on. But then we also had a follow-up with a for loop that printed out the values at each instance of n, okay, or each index. All right, so there's a 2-part now to this print out. And once again, we can handle this slightly different. There will be a little bit of redundancy in our code, and you'll see that in just a second, because what we're going to do is we're then going to handle the parametric version. And if you go back to your screenshot that you did earlier for the Projectile 1D version 4, if you were to do it parametrically, or in other words, arguments from the command line, you would have 6 of them. So what we're going to do is we're actually going to borrow this line of code, and I'll come down here one more time, paste this here, change this to 6, and change my /i to /p. And assuming that I've actually got 6 arguments, then the y init is going to be equal to a to f of our argv square brackets 4, and then our n is going to be equal to a to I of argv square brackets 5. And once again, note, we need to change this later. We need to address this later. I'm just going to word it the exact same. This will be handled in another video. So for right now, I'm just going to hard code n equal to 11 with a note to remove later. But at this point, then, we simply make a call to our Projectile 1D version 4. Once again, with our y init, our time vector, our y time vector, and our vy time. And then lastly, the n, where n is the number of elements. And just like before, we want to turn around and we want to print out the results. So we're going to go ahead and print out this table. So if anything, what we can do is we can come up here and we can borrow the code and just copy and paste it. Now, what I want to do to give you something to work on, I'm going to actually stop recording here. I'll pick back up after I have finished off this example. And then what we'll do is we'll test each one of our functions. Okay, so you want to continue on with our 2D version 2, version 3, version 4, as well as the Beam version 2, version 3, and version 4. So I will see you guys in just a little bit.